Confined spaces and other similar locations can be unsuspecting chambers of death unless you know the hazards and are prepared to avoid risks. One of the important parts of avoiding risks is to know about hazardous air or the hazards contained in the air you're going to be breathing in confined spaces. You all heard about people who refuse to install smoke detectors in their homes because they have an old faithful dog that sleeps in the bedroom. If the house catches on fire, the dog will supposedly wake up and start barking. It's a foolproof smoke detector. How about the miners in the good old days? They carried small birds into the mines to make sure the air they were breathing could support life. They never killed any rats either, because these animals told them the breathing air was okay. When the rats started dying, it was time to leave the space. Well, those days are gone. Dogs can be overcome by smoke while they're sleeping just like human beings, so the dog alarm won't always work. In today's working environments, the air must be monitored by sophisticated air monitoring devices. You can't leave anything to chance. The first rule to remember is you never know what you're going to find, so it's best to check it out. Some of the more important gases to test for include oxygen deficiency or not enough oxygen in the air to support life. They also include carbon monoxide, hydrogen sulfide, carbon dioxide, and many combustibles or flammable gases. Each gas is different with different hazards. Some of the sources of these and other gases include decomposition of organic matter, leaks from pipes, chemical mixing or spills, or cleaning operations. There are some people who say they can rely upon their senses to detect certain gases or vapors. Many gases have very poor warning properties, or you could be affected before you have time to react. Hydrogen sulfide, commonly found in sewers, has a distinct odor like rotten eggs. Hydrogen sulfide takes away your sense of smell, and in a very short period of time, say 5 minutes, you may not even be able to smell it at all. If your sense of smell is gone, you can be overcome because you can't smell it. Let's take a look at some of the gases you may encounter and learn a little bit about them. We won't cover all potential hazards, but to give you an idea of the problem, we'll mention a few of the more common gases. We'll begin with hydrogen sulfide. H2S is one of the most toxic and asphyxiating gases in confined spaces or areas where ventilation is very poor or non-existent. OSHA limits exposure to this rotten egg-smelling gas to 10 parts per million based upon an 8-hour shift. Hydrogen sulfide is produced by the decomposition of organic matter. This occurs in a variety of work environments such as landfills, mines, breweries, sewers, and natural gas or other organic decomposition environments. The minimum protection for this type of atmosphere is an air-supplied respirator or a self-contained breathing apparatus. You determine if hydrogen sulfide is present by using a monitoring device. Oxygen is an odorless, colorless, tasteless gas that supports life and makes combustion possible. Oxygen makes up about 1/5 of the atmosphere by volume, which is approximately 20.99%. Too much oxygen or too little oxygen in the air can be quite hazardous. When the oxygen level falls below 19.5%, the air can be life-threatening. When the oxygen level decreases, quite often, other gases rush in to take up the space, such as carbon monoxide and carbon dioxide. Most people won't know when they're in an oxygen-deficient atmosphere. At 15 to 19% oxygen, individuals may have decreased ability to work, and their reasoning and coordination may become impaired. At the 10 to 14% range, respiratory problems may occur. Few people recover from spending more than 5 minutes in an atmosphere containing less than 8% oxygen. Quite often, lack of oxygen to the brain can render an individual permanently brain damaged, if not a fatality. Carbon monoxide is also an odorless, colorless, chemical asphyxiate with toxic and flammable properties. The gas is associated with automobiles and combustion engines, but it's also found in mining operations, iron production, and chemical processing. When mildly exposed individuals may feel tired, uncomfortable, or experience headaches, in high concentrations, carbon monoxide is considered immediately dangerous to life and health. Carbon dioxide is a normal product of human and animal metabolism and is relatively non-reactive and non-toxic. That's one reason it's used in many fire extinguishers. Carbon dioxide is heavier than air, so it can settle at the bottom of pits, confined spaces, and other low-lying enclosed areas. It's something that also needs to be monitored for hazards. There are a wide range of flammable and combustible gases that must be evaluated in these confined spaces before entry. It's hazardous to work in an area where a spark can set off an explosion. You have to monitor the air for potential hazards, then reduce the hazard before entering. Okay, now let's discuss the monitoring and what to look for. Keep in mind, we're not listing all the hazards, just some examples to make you aware of what monitoring is all about. Each organization must adopt their own monitoring procedures based upon the environment, potential hazards, and conditions of the area. A good starting point for monitoring any area is to look for oxygen. It should be monitored before, during, and after entry as conditions change. You have to have enough oxygen to support life, so an oxygen-deficient atmosphere would not be safe to work in unless you were protected from the deficiency. To effectively monitor oxygen, toxics, and combustibles means knowing where to look for workers as well as the gases. Some workers may move in and out of possible exposure areas during their work period. It's also a good idea to use a combination of personal and area monitoring. Area monitors on the wall or on certain areas can offer an early indication of what people may be exposed to. You also need to know what concentrations of the toxics or gases are reaching the individual. When monitoring, remember that different hazards may be located at the top, the middle, and the bottom of the space. Some gases are lighter than air, some heavier. Methane is found at the top because it's lighter than air. Hydrogen sulfide is heavier than air, so it's on the bottom. What happens when you're not sure about a particular gas? You know it will support oxygen because it's tested okay for air. Should you ventilate all the bad gas out of the area? You must still monitor for potentially combustible or flammable gases. Suppose you find methane in this space. If you simply ventilate the gas to get rid of it, you may be adding just the right amount of air to the mixture, causing it to become explosive. A spark or ignition source could set it off. Find out what you're dealing with, then take the necessary action to reduce the hazard. It may require purging the space with an inert gas such as nitrogen to lower the flammability hazard, then ventilate. What are some of the things to watch for when monitoring potential hazards? Be sure your equipment is calibrated. Most test equipment requires frequent calibrations to make sure it's working the way it's supposed to. Next, make sure you do enough sampling to affect as many conditions as possible. If you have a change in the environment, such as a welding operation, you must sample again after the operation to ensure the area is safe. Frequent sampling is a good idea, as the environment may change frequently in the space. Make sure you know what chemical mixtures are compatible with other chemicals, if chemicals are used in the confined space. This is particularly true of cleaning operations, which may react to the area being cleaned as well as the different chemicals used. Make sure the person monitoring knows and understands the meanings of different situations that may come up during the operation. If you're not sure about the differences between a particular reading, say combustible gas levels, you could get into a hazardous situation quite quickly. Reading the meters correctly is a very important responsibility, as well as knowing what to do when an emergency does arise. Keep in mind that testing equipment does have limitations. You have to know what these limitations are and what to do about them. When you introduce a variety of potential hazards such as oxygen deficiency, toxic vapors, combustible gases, or flammables, you have the potential for life-threatening situations. You just can't take chances. The best advice is to follow your organization's policies and procedures, and if you're not sure about something, be sure to ask questions. Calibrate your testing equipment and make sure the person operating the equipment understands what monitoring is all about. It's just good sense, and the people who work on these areas will certainly be appreciative for taking their safety and health so seriously.